Hello everybody, my name is Đăng. Let me introduce you about our group. Our group has 3 members, me, Đức and Đăng. We are here to present to you about the topic. Are you ready for the quantum computing revolution? At first, I will talk about the quantum physics has already changed our lives. Thanks to the invention of the laser and the transistor, both products of quantum theory, almost every electric device we use today is an example of quantum physics in action. We may now be on the brink of a second quantum revolution as we attempt to harness even more of the power of the quantum world. Quantum computing and quantum communication could impact many sectors, including healthcare, energy, finance, security, and entertainment. This century predicts a multi-billion-dollar quantum industry by 2030. However, significant practical changes need to be overcome before this level of grand-scale impact is achievable. The next quantum versus classical. Although quantum theory is over a century old, the current quantum revolution is based on the more recent realization that uncertainty, a fundamental property of quantum particles, can be a powerful visual at the level of individual quantum particles, such as electrons or photons. It's impossible to precisely know every property of the particle at any given moment in time. In the quantum world, we must use the language of probability rather than certainty, and in the context of computing based on binary digits of 0 and 1, this means that quantum bits has some likelihood of being a 1 and some likelihood of being 0 at the same time. In fact, that would lead to errors in calculation, but revolutionary idea behind quantum information processing is that quantum uncertainty, a fuzzy in between superpositors of 0 and 1, is actually not a bug but a feature. It provides new level for more powerful way to communicate and process data.
My name is Đức. Now I will talk about the preparation for the quantum future. The quantum race is already underway. Governments and private investors all around the world are pouring billions of dollars into the quantum research and development. Satellite-based quantum key distribution for encryption has been demonstrated, laying the groundwork for the potential quantum security-based global communication network. IBM, Google, Microsoft, Amazon, and other companies are investing heavily in developing large-scale quantum computing hardware and software. Nobody is quite there yet. This is a Sigma, which is a quantum computer. It's designed by Google. While small-scale quantum computers are computational today, a major hurdle the scaling up to the technology is the issue of dealing with the errors. Despite a theoretical framework for quantum error correction has been developed, implementing it in an energy and resource efficient manner poses significant engineering challenges. Compared to bits, qubits is incredibly fragile. Even the slightest disturbance from the outside world is enough to destroy the quantum information. To preparing for quantum future, the business leader should consider developing strategies to address 3 main areas. Current data encryption protocols are vulnerable not only to future quantum computers but also to the ever more powerful classical computer. New standard for encryption is inevitable, changing over to the quantum scale architecture and supporting infrastructure for data security will require planning, resource, and quantum expertise. Nobody could have predicted the myriad ways that classical computers impact every aspect of our lives. Predicting quantum application is equally challenging. That's why, in order to fully tap into the potential of quantum computing, business leaders and aspects in different sectors such as health, finance, and energy must connect with the quantum researcher and the hardware software engineer. This will facilitate the development of industry-specific quantum solutions tailored for the currently available quantum technologies or for the future scalable quantum computing. Who will develop and have access to quantum technology and how will users engage with it? The impact of AI and blockchains have demonstrated the need to consider the social, the ethical, and environmental implications of new technology. It's early days for the quantum industries. Thus provides a rare opportunity to embed inclusive practice from the start and build a responsible and sustainable roadmap for quantum computing.
Quantum communication is the most interesting application for transmitting information channel again enveloping by means of quantum cryptography. Quantum computing, particularly important application of quantum computing, might be to simulate and analyze molecular for chip development and material design. One outcome of the probabilistic nature of quantum theory is that quantum information cannot be precisely copied. For a scarcity length 6e game changing, hacker trying to copy quantum key used for encrypting and transmitting messages for fail. Hacker even if they have access to a quantum computer or other powerful resources. This fundamentally unhackable conception is based on the lack of physics and not on the complex mathematical algorithm used today. While mathematical encryption techniques are vulnerable to being grasped by powerful enough computers, grasping quantum encryption is fundamentally different from correct encryption. This based on mathematical complexity are fundamental different from classic computer. A peculiarly informational application of quantum computer might be through the simulate and a laser molecule for drug development and material design. A quantum computer is incredibly still for some tech because it was operated on the same law of quantum physics as the molecule. It is simulating using a quantum device to simulate quantum chemistry called be fast more effective than in the flashing classic supercomputer today. Quantum computers are allowed ideally subject for slowing complex optimization. Take a performing fast search of unsorted data. This could be relevant for many applications, for sorting climate data or health or pharmaceutical data, to optimizing supply chain logistics or workforce management or traffic flow.